Stuart again. Today we're going to talk about cloud migration and modernization planning, otherwise known as the rule of thirds. Let's get started with a lemma that cloud migration modernization projects are bounded by duration and not effort. So most estimating methodologies would have you estimate on the basis of effort. And there's a series of curves, long established, that say that if the number of effort points is so-and-so, that your project plan should look like this, and you should have this number of developers and the proportional ratio of supporting personnel. But migration projects are taking an existing piece of software and rehoming it to a different data center. In my practice, that's mostly to the cloud. Although these days, any reasonably modern data center technology counts as a cloud. VMware and OpenStack are great examples of that. And what we've discovered is that the pregnant lady rule, coined by Brooks, applies. That is to say, it takes one lady 9 months to have a baby, and adding a second lady to the equation does not half the time. In migration projects, we are, more than any other project type, at the behest of others. We need to do an ensemble delivery that involves all of the IT roles, and we have to realize that things like provisioning and configuring databases or transforming technologies take time, but it's not the time that can be measured in effort. It's a time that's generally measured in time boxes. For remediating, for example, security vulnerability. You could, I suppose, given a certain vintage of software, put a nearly infinite amount of effort into remediation. But in a migration, that's not practical from either a budget point of view or from a timeliness point of view. One of the rubrics that's true is the shorter you can make the migration project in duration, the more likely it is to be successful. And at the outermost edge of that is 3 calendar quarters or 9 months. And so based on that wisdom of doing migration after migration after migration, we have come up with an approach, and we're going to talk about it. So let's start with how we do the analysis to figure out migrations. We have business units. Business units owned ecosystem. An ecosystem is a collection of one or more apps and dependencies that deliver a stream of business value. A deployable unit is code that we wrote that can be deployed. So websites, web services, tasks, jobs, clients, schemas, and so on. And a dependency is anything that you need to make your ecosystem go outside of the deployable units. So database engines and third-party services and queues and networking and so on. They're all things that are typically connected to your app by IP networking. And so we want to know some things about it, like who owns it and, what kind of connection and so on. And we want to capture those during the analysis. So there's a taxonomy, an organizational principle that goes along with this. A business unit can own one or more ecosystems. Ecosystems are comprised of deployable units. Business units also own dependencies. Some deployable units rely on the dependency and others don't. And so you get a many-to-many graph. Notice that dependencies are extremely rarely only used by a single deployable unit, which is why we separate. So even though technically a schema for a SQL server might be considered a deployable unit, once it's deployed and in place on the engine that is SQL Server, it becomes a dependency because multiple deployable units probably call it. And so the quote ownership relationship is a diffuse one. Also know that other people's deployable units can call us. And so we have a dependency relationship where they are dependent on us, and that's a legitimate dependency. So the cloud methodology is 4 steps: ingestion analysis, work breakdown, execution, and programming. So portfolio ingestion analysis is comprised of 2 parallel tasks where our goal is to enumerate the orgs and ecosystems that are in scope for the migration. And we want to end up with a backlog and an inventory. A backlog of things we need to do and an inventory of the things we have, including existing infrastructure. So we'll, at the top swim lane, identify the DUs. We'll do the analysis process called SNAP. More about that later. And for each deployable unit, we'll come up with a size, a disposition, a list of issues and risks. We'll also do an automated survey of the network and an automated assessment. Typically, infrastructure discovery allows us to find not only the relationships between deployable units, but where the deployable units are physically deployed onto what servers. And for the deployable units, they help validate the dependencies because automated tools can see things. We'll also do an assessment using code quality and security tools. And from that, we'll end up with a dependency map, but we'll also end up with a list of technical debt, which will go into the back. So SNAP is a methodology developed by Dell and Pivotal. It's done by deployable unit. Typically, we try to capture 3 pieces or chunks of information. We have a section about particular programming language. So Java on Gradle, for example, or .NET Core on Linux, or Node.js on Windows, and so on. And the survey part is designed to ask questions with one goal in mind. What is it about that software system that could hurt us when we're trying to migrate? In other words, things that will be more difficult, things that we will have to modernize, things that will make the system less secure, less trustworthy, less stable, and so on. And of course, non-functional requirements. We want to pay particular attention to performance goals, security goals, SLAs, and this is where stakeholders who are interested in the non-functional requirements get to weigh in. And of course, we want to identify the dependencies for this deployable unit. Among other reasons, we're going to need that metadata when we start making firewall rules up in our new infrastructure. SNAP's designed to be done in 10 to 15 minutes a deployable unit. Typically, we start a session in person with the different technical and business stakeholders, and we take, usually in an hour, you can get through 3 snaps. But along the way, the team learns how the snap process works, and they get used to the questions on the snap and what they mean and what the grading system on each question means and so on. And then they can pursue filling those out on their own with whatever follow-ups are required. But that's the general time investment, 10 to 15 minutes after the initial training. So what are we trying to focus on? We're trying to focus on the overall sizing we came up with. We use t-shirt sizes because until we do some POCs where we move some representative apps up into the cloud, we probably won't have a good appreciation for what small, medium, large, and extra large mean. And remember, this is one single deployable unit. And so in the aggregate across all the deployable units, we use that to then size it into a number of quarters and a number of pairs. More about that in a bit. Do we have explanations for the things that are not standard for the platform? So for example, if we're using Node.js and we're not using NPM as our package manager, we should probably get an explanation. Do we have additional characteristics and non-functionals? We need to capture that. And when we go back and we review all the snaps and we make a summary, again, does it map onto our pairs for number of quarters model, right? We want to estimate in whole quarters. More about that in a minute. And so other things, right? Other non-functionals. But basically what we're looking for is what are the list of things for this deployable unit that will make our lives miserable if we were trying to move this to the cloud. In other words, what do we need to remediate to move this to the cloud and be successful? Old versions of runtimes, old versions of operating systems, and so on. Practices and technologies that are no longer supportable, and so on, are all areas that you should care about. So then we want to break that down. So by ecosystem, right, we were working at the deployable units. We're going to roll those up into an ecosystem. We're going to have a parallel process of estimating the overall level of effort, again, in quarters, and we're going to do that by number of pairs. We're going to figure out a schedule. We're going to socialize that schedule because remember, the business may have other things going on. They may have agreed upon maintenance windows. They may have agreed upon releases. They may have high priority features that need to ship and so on. And for each dependency, we need to have a plan. And in some cases where we're replacing dependency types, that is to say, we're switching, for example, from MSMQ to RabbitMQ, we probably ought to do a POC and figure out how to productionalize each of the dependencies. And again, we'll update our backlogs or our inventory as a result of that process. So we want to think about how to think about planning. If we can't do our normal BAME curves or agile curves or Kanban estimates, then what we need to do is we need to use our t-shirt sizing model to plan in units of whole quarters and number of pairs. And generally speaking, we come up with the number of pairs we need to do the development, and then we supplement that with QA and DevOps, and then across any number of programs within that. So across ecosystems or parts of ecosystems, we're going to need some overhead roles, project managers, product owners, cloud architects, and so on. So you'll notice in our little table, end up sizing to 1, 2, or 3 quarters in duration. And we actually roll those down by a number of weeks. We say 1 quarter is actually 12 weeks, not 13. We say that 2 quarters is 24 weeks, 3 is 36, and so on. That gives us some elasticity to deliver within the envelope of a calendar quarter or quarters, but sets an aggressive tempo that's appropriate. So that's where the elasticity comes in. So here's a timeline example of the rule of thirds. That is to say, for a particular length of project, like 24 weeks, we break that into thirds, and we say that each third has a theme or a goal. And so the goal of the first third is get everybody onboarded, everybody working. And at the end of the first third, you should be able to demo the system in the development environment, even if you had to provision and deploy and fiddle it manually. And at the midpoint, we say our goal, so that's halfway through the second third, is that it's mostly automated, it's running in QA, and we're actually doing our functional and performance testing and so on. At the milestone that marks the end of the second third is that it is running in QA and is passed. And so the theme of the last third is productionalization. So that is getting the environment into production, figuring out what our customer migration plan is, getting all the sign-offs and approvals, validating the production environment, and so on. And at the end of that, we're ready to start migrating users. Notice that the time that we compute is up to, but not including, the migration of users, because the business may have other agenda. They may want to move the users in waves and so on. And so the migration team is going to, at the end of the third, hand the system back to the business's developers, and they will manage the customer migration and own the system going forward. And typically the migration team will roll off and roll on to another migration until they're all done. So it's important from a planning point of view that we don't want to take a dependency on the business onboarding customers. There may be customer communication, there may be contractual things, whatever. What we do want to be able to say, though, is at the end of the third is that it's ready to take customers, fully productionalized. So if you go watch our video on modern development, we speak to that in more detail. And so the execution, that is the thirds, right, are these infinite loops of analyze code, test, build, execute, right, determine, provision, and so on. So typically we have 2 parallel paths, a code path and an infrastructure path. And we're going to keep doing that and looping on that environment by environment, typically dev, QA, UAT, and production. A lot of people like to have a separate perf environment. If that's what you want, go ahead and do that. And so we're going to iterate on that until we hit each milestone to the required specification. And then at the end of each migration, we're going to do a code review, because sustained engineering requires constant and never-ending analysis and improvement, right? So we're going to collect the metrics and lessons learned. We're going to analyze. We're going to extract actions. We're going to communicate those actions, and we're going to improve, and we're going to start our next thing. And we're going to do that over and over again, because as we do more and more migrations, we're going to learn things about the platform we're migrating to. We're going to learn things about the internal latency and politics of our environments and business units, and we're going to learn about things about the various technology stacks that we didn't know before that we're going to start paying attention to, and process things that were bumps that bruised us. And so sprints, traditional agile, are generally not appropriate for migration and modernization programs. In fact, Kanban is. And so we take our backlog and we break it up by which sub-team or sub-teams get it. And in almost all cases, that is a serial affair. That is to say, DevOps may get it first, and then the developers attempt to provision to it, and then the testers test it, and the business says, yea, verily, this is how it is. And the idea is that we try to move as many things to the right as we can every day on our Kanban board, and that we focus on the things that block us, and that each team tries to resolve their blocking issue. And if they can't, it rolls up to the bigger team, and everybody pounds away on things that are red, that are blocking, until they're resolved. Let me just be clear, though. The reason that we primarily make these projects duration-bound and not effort-bound is that we're going to run into problems. In general, the reason we make these projects duration-based is we know we're going to have blocking issues, and those blocking issues will take time as well as effort to resolve. But if we look at the time they take to resolve and compare it to the level of effort they take to resolve, the time they take to resolve is much bigger than the effort. So when blockers happen, we should expect them, but we should also act on them with energy and as a group to pound them down. So here's a typical Kanban board that I often use. I'm a minimalist. I like 5 columns. If you like more columns than that, that's great. Everything starts in unstarted, and everything is done when it's piled up in verify. If you like a wall with sticky notes, you can use that. There are dozens of open source and paid Kanban boards that you can use. They're readily available. But the idea is that for everything we know we need to do, and for all the new things we're going to discover, because in our analysis phase, we'll be lucky to get 80% of the things identified, especially for our earlier projects. By the time we're moving our 10th, 15th, or 20th ecosystem, and we should be a machine, right? And that red unexpected things will be rare. But initially, right? And the idea is that we roughly prioritize them under each team or role. So, DevOps has their priorities, and there are natural things that have to be done in a certain chronological order. For example, if you're building something up in the cloud, you have to make a project first, and then the project is a container that holds things, and so you need to create networks inside of there and assign roles and permissions and identity and do all those other things. But the idea is we want to be able to work as highly parallelized as possible, so that when things are in a block state, there are other things we could be doing. And remember that documentation and testing is never a waste of time. So here are some things that historically we have noticed make migrations to the cloud kind of miserable. Mini computing mainframes, custom hardware, fax, dedicated connections, odd ports to the firewall. One thing that we've noticed is that there's nothing like moving your data center to bring up to InfoSec and compliance all the ways that you violated the InfoSec and compliance policy as an application system. And probably the people who did it are long gone, and you've just been quietly living with it if you're an app owner, but that doesn't make it okay. Third-party components, licensing, will it even run in a cloud? Are you allowed to run it in a cloud? You'd be surprised how much the licensing can vary. So you need to go and find all of your dependencies and, check their licensing. Inbound email, inbound FTP, and file uploads cause horror and concern. Inbound email is completely doable in the cloud, but you probably are going to want to have a slightly different architecture for it than you did in the data center. The other thing is you probably want to centralize some of these things. In the data center, we get incredibly spoiled about the fact that we probably have pretty hotsy-totsy hardware sitting on multiple gigabyte Ethernets on top of a SAN. And, fiber channel and 5 gigabyte networking. And so we get incredibly high IOPS from our mounted disks on our VMs or our storage clusters. And moving terabytes of data around is often a matter of rewriting the pointers to them as opposed to physically moving them from one volume to another. But these things are different in the cloud, and we have a nice video about that. Insecure protocols, again, InfoSec's probably going to notice. So you've had this one partner and they've been using HTTP because they've never really mastered HTTPS, and now it's really noticeable. And security, whitelisting, or IP endpoints are going to change. By the way, anyone who relies upon IP whitelisting without route checking is kidding themselves that they have security. You got to go back and look at your non-functionals, your contracts with your customers, maintenance windows. Sometimes customers get the right to sign off. They're going to be extra picky about where they want their data stored and so on. And all these things are going to inhibit your ability to flip the switch and say the system is customer ready. So in other videos, we've gone over the 12-factor app transformation checklist. Reminder, this is it. The ones in purple are the fast 5. If you're actually planning to refactor some of the code that you're moving to the cloud, then you should definitely visit this. Likewise, if you watched our modern DevOps, you'll recognize this checklist as a list of things you should pay attention to when moving things to the cloud from a DevOps point of view. I will put a stake in the ground and say that I have never seen a successful cloud migration or even data center move that didn't have fairly mature DevOps backing it up.